Okay, so in the previous video, we had just got to the point where we had made this, illustrated how this estimation had been made for the variance. It's the VIX formula for the, and we estimated the variance of the earlier chain data for the options, the out of the money put and call options, and we'd managed to work out F1, T1, and then we hadn't worked out the summation, but I took an example given here, so I tried to replicate the example here with the strike price of 1,370 for the put option, and then illustrated how in turn we could use that estimate, right, to finalize the VIX estimation. Now the value that we had obtained here was only going to be a small subcomponent of the actual variance figure that was being worked out, and in fact we had to repeat that exercise, although I didn't do it in the spreadsheet, haven't done it yet. But that single estimation of where we have this 5328, that had to be repeated for the relevant out of the money options. We took the summation, we got 0.000632, and then in turn we had to multiply this figure. Importantly, in the estimation, we had to multiply this figure by 2 divided by T1. Okay, so once we had obtained this figure, then we used it below here, and this estimate then was adjusted, so this figure here was multiplied by 2 divided by T1, which then produced this number, and then in turn we subtracted away. We had to estimate 1 over T F1 divided by K0 minus 1 squared, and that figure then was subtracted just the once, and at the end, when we had taken the product of this and 2 divided by T1, remember the 2 divided by T1, the resulting value for the near term options then are summed, and then once we sum them and obtain this figure here, we then multiply by 2 divided by T1, which produced this number here, and then finally we obtain this number by implementing what's in the square brackets, the product, and we subtract it away. Okay, so in our spreadsheet, the figure that we had arrived at ultimately of the 0.01849, 184949, that figure is actually the figure we had here. So it's the sum, the summing of these terms here multiplied by the T1 divided by 2 produced this number here. So when we multiplied by 2 times T1, we got this figure, and then we subtracted out and we got the 0.01849. Okay, so that was the last number we had obtained here. Okay, so this number here corresponds with the number, the 0.1846, 0.18463, right, corresponds with the number that we have here. Then once that estimate was made, we then had to follow up that estimation by repeating the same exercise, but for the longer term, for the next series. So the estimates that we had made here in terms of the near expiry option data, we had to repeat the same exercise for the next contract, 32-day option data, and again estimate the value that we have here ultimately multiplied by 2 divided by T1. Okay, so to go from this number here, the 00083, right, the 00083, we had to multiply that by 2 divided by T2. Okay, and that would yield us this. Let's take this down a notch. Okay, so the number we obtained here was then multiplied by 2 divided by T2, which in turn produced this figure. And then we had to subtract away 0.000169, which was obtained here. And again, that's just repeating what we had done before on this side, but now doing the same estimation, but for this set of data here in the 32 day expiry option data. Okay, and finally we subtract away. So again, we repeated what was done here. We repeat again, but note we used F2, which we had estimated before, and T2, otherwise the same, and that figure was subtracted away from this other figure mentioned previously to produce the 0.01822. Now, we still had to make these figures here still had to be used again in order to calculate the VIX. So we weren't done. In order to calculate the VIX, the VIX is supposed to represent a 30-day weighted average of Q of the variance for the shorter option data and the variance of the longer option data for the 32-day expiration. We have to interpolate. To interpolate, we take the figures that we had just worked out for the Q1 squared here, given here, and the Q2 squared given here. And then we had to, as before, we took the T1. Okay, so we had to calculate this before, and the Q1 squared obtained before, and then we scaled it, right, or weighted that by taking NT2. Now NT2 here is the number of minutes to settlement of the next term option. So T1 is given in terms of years, T2 is given in terms of years, NT2 is given in terms of minutes. Okay, so we had worked this before, the 35,000 and the 46,000. Okay, now to see where we got those figures from again, we might go back into the spreadsheet to the first worksheet, and I'll paste in the final bit of the estimation just so that we note. And T1 and T2 in terms of minutes, T1 in terms of minutes was equal to 35,924, and T2 in terms of minutes was equal to 46,394. Otherwise, in terms of years, right, so if we took this as being the minutes, then in terms of years, right, we divided that by the number of minutes in the year, and that was given respectively as the 0.68 and then the 0.88. Okay, then what's left to be done here in terms of our estimate? Well, we have to explain the 43,200. The 43,200 is the 30-day window expressed in minutes. Okay, so there's 43,200 minutes in 30 days, and then that repeats here again, 43,200 minutes in 30 days. Otherwise, the number of minutes in a 365-day year is 500. Okay, so the number of minutes in a year, if we take 365 by 1440 number of minutes in a day, 365 days in a year, that's 525,600. That's what the number of minutes in any given year. The number, so and that figure appears here, and then we divide that figure by the number of minutes in a 30-day window, and again the 30-day window is 43,200 minutes. 43,200 minutes. When we work this out and take the square root, let's go back into our estimate again. We find that the value we obtain is 0.13685, and this figure for the 13.69% for the VIX, that is our VIX result. Okay, so actually there's quite a substantial amount of computation involved. Later on I'll try to put up a relatively fast automated estimation using VBA, where hopefully I can replicate the results that we have here. But in terms of the making the estimate, the calculating the VIX involves using quite an amount of data normally. So in a sense, to show a manual estimation with this type of relatively realistic type example is a little bit involved, and eyeballing it is helpful, but it's also, given the scale here, it's a little bit difficult to track. The key thing to note about the VIX is that it is taken now as being a fairly significant index in terms of gauging the amount of nervousness in the market. We know from historical experience it's elevated during periods of uncertainty. When the value of these larger indices like the S&P 500 is falling rapidly, the VIX tends to elevate, and that seesaw relationship that we observe is proving useful in terms of allowing the CBOE to set up new types of financial products which trade futures. So we if you like, the CBOE computes daily and at shorter frequency the VIX estimate, and that allows them then to create additional future contracts and additional option contracts that trade on the back of that historical time series, which seems slightly counterintuitive, that the implied volatility of an option is then taken to create a series, which in turn allows us to produce new financial products where we trade future contracts on the back of the VIX and option type contracts on the back of the VIX also. The fact that it's successful and captured public imagination tends to suggest that there's quite a bit of interest in the product and it serves some economic ends. Okay, so I hope to produce another video later where I automate this estimation, and instead of taking 6 video clips to outline the main detail of the estimation, it can be done in one 15-minute time interval.